we have y equals sine xy, and the question find dy dx. Always do math with the pencil. Again, the rule I'm using, the derivative with respect to x of sine of u is going to be cosine of u times du or u sub prime or du dx, or u sub prime is the same thing. So here the derivative of y, which is dy dx, instead of the sine is going to be the cosine of xy times the derivative of the inside, which is xy. And the derivative of this I have to use the product rule. Remember, f is the first one, which is x. G is the second one, which is y. The derivative of f is 1. The derivative of g is dy dx. Derivative of f is dx dx, which is a 1. So the product rule says f times g sub prime. F times g sub prime. F is x times dy dx plus g, which is y, times f prime, which is 1. In case you forgot, for the product rule, it's f times g sub prime plus g times f prime. That's what I'm using. That's how I came up with that. Distribute that. X dy dx times cosine xy plus y times cosine xy. Bring this one to this side, becomes a minus. Equals what? Y cosine of xy. Factor dy dx out. And again, finally now to solve for dy dx, we divide by all of this. All of that. So what is dy dx? Y times cosine of x of y over 1 minus x cosine x of y. And that should be the answer. Let me take a look at it closely. Yes. Derivative of sine is a cosine. The derivative of this is the product rule, the first times the derivative of the second, plus the second times the derivative of the first. And when you multiply them, I pulled these in the front. Factor this, that looks good. That was number 7. Let's look at 8. Number 8, maybe I write small too. Doesn't look like a big problem. X equals secant 1 over y. Again, just a reminder, the derivative of secant u, what is the derivative of secant u? Isn't it secant u tangent u, yep, I heard that, times what? U sub prime, the derivative of u. Don't forget the derivative of u. U here is 1 over y. So when you look at that example, u is really 1 over y. Or you can write that y to the minus 1. That's what u here is. So what is the derivative of that? What's the derivative of u? Isn't that minus 1 y to what power? Minus 2 times what? Du dx. Or dy dx here. Dy dx, not du. Or dy du. Sorry, I'm not using x here. I'm using y and u here. This will be actually, if I do it, you know what? Eventually it's going to be dy dx. You know, I'll just leave it. Leave it that, because that's going to be my derivative. This piece times dy dx. So here we go. What's the derivative of x? 1. What's the derivative of secant? Is secant 1 over y. Tangent 1 over y times the derivative 1 over y, which I just did that, which is negative y to the minus 2 times dy dx. That's the derivative of 1 over y. Okay, let's clean it. There'll be a minus. I like this to go on the front. And to get dy dx, what do? Don't you want to divide everything by this one? Let's think about this. Could I rewrite this? This is fine, actually. There's nothing wrong with that, but they're probably going to play with the algebra. You can write this 1 over negative y to the negative 2 times 1 over secant 1 over y times 1 over tangent 1 over y. I could write it like this. And let's simplify each one of them. When you multiply the top times the top times the top over the bottom times the bottom times the bottom. You end up with the same thing. But the nice thing about doing this becomes 1 over a minus 1. That's a negative y squared. When you bring y to the minus 2 to the top, it becomes y to the plus 2. What is 1 over secant? Where is it on the board? Secant is what? 1 over cosine. So what do you think 1 over secant is? That's just the cosine. What's 1 over tangent? Look on the board, number 6. That's the cotangent. So that's your answer. They're probably going to leave it like this. The other one is good too. They're probably just not going to leave it like that. They probably change it to this. Notice how tiny the problem doesn't look that big. Secant. Those are the deceiving one. When you look at them, go, oh, that looks like a straightforward, easy one. It is really straightforward as long as you know it's secant tangent times the derivative 1 over y. And again, the derivative 1 over y, you make it y to the minus 1, the derivative of that minus 1, y to the minus 2 times dy dx. Then you find. Uh, 13. Find dy dx. The question is, find dy dx. Two questions actually. That's the first one. The second one, find dy dx at the point 4, 3. So they want two of them, part A and part B. Let me find dy dx first. I have to use implicit differentiation because I can't really solve this for y. So let's take the derivative, go left to right. What's the derivative of x cubed? Good. Times dx dx if you want to, which is a 1. What's the derivative of y cubed? 3y squared. Keep going. Dy dx. Equals. There's the 8. I'll put in the front. Let's take the derivative of x times y. This is a multiplication, so which rule we got to use? The product rule. The first, which is x, times the derivative of y, which is what? Dy dx, plus y times the derivative of x. The first times the derivative of the second, plus the second times the derivative of the first. Y times the derivative of x, which is what? 1. Minus the derivative of 5, which is what? 0. This will be 8x dy dx, bless you, plus 8y. So I want all the ones with dy dx on one side, bring this one to this side, all the other ones on the opposite side. So I will have 3y squared dy dx minus 8x dy dx. On the other side, you're going to have what? 8y minus 3x squared. I can factor dy dx out. And what is dy dx? 8y minus 3x squared over 3y squared minus 8x. In part B, it says at the point 4, 3. So what's the derivative of that point? X is 4, y is 3. 8 times 3, which is what? 24 minus. What's 4 squared? 16. 16 times 3, is that 48? Y is 3. 3 squared is 9. 9 times 3 is 27. X is 4. 8 times 4, 32. So that's a negative 24 over what? Negative 5, which is 24 over 5. So at that point, the derivative, which is the slope of the tangent line, is that value. Wait a minute. Uh-oh. That was 12. Sorry. I'll number that 12. I thought it was 13. Okay. Here comes 13 now then. Maybe the 4th of July get to me.
Too much wings.
Oh,
You love the wings.
too much food, yep. I was rooting for the U.S.-Japan game to go overtime because it's 50 cents wings at Pizzeria Uno, as long as the game is going on. I didn't care who won, I just won the wings. Find the derivative at the given point. At 0, 0. Again, just a quick reminder, those trig identity are tricky there. The derivative of tangent u is what? Secant squared u times u sub prime. And u is this piece right there. That's what your u is in this case. So let's find the derivative. Derivative of tangent will be what? Secant squared 5x plus y times the derivative, what's on the inside. Well, what's the derivative of 5x? 5 plus what's the derivative of y? Derivative of y? dy dx, right? Equals, what's the derivative of 5x? 5. So if you distribute that, you have 5 times secant squared 5x plus y equals, not equals, plus, I'm sorry, plus dy dx times secant squared 5x plus y equals what? 5. I can move this to the other side. Dy dx times secant squared 5x plus y equals, I can factor a 5 out, 1 minus secant squared 5x plus y. So I factor that 5 out of both of these. When you bring this one to this side, it becomes a minus. I took the 5, put it in the front. What is dy dx? If you want to have fun with this, actually, we can. Look at equation number 9. Number 9, if you look at it, it says what? Secant squared equals what? 1 plus tangent squared. Secant squared theta, we'll use theta, equals 1 plus tangent squared theta. If you play with the algebra, I can do color things. I can move the secant squared to this side, the tangent squared to this side. I'll have what? Negative tangent squared theta equals 1 minus secant squared theta. Everyone see that? I just played with algebra. So why? Because I'm looking at this. Yep, good. I'm looking at this piece here, 1 minus secant squared. See it? Can you see it like in highlight now? Does it show up? Barely, yep. Try to highlight with yellow. 1 minus secant squared. I can replace that with negative tangent squared. So I can take this problem now and write that dy dx equals, that's really the reason why I factor the 5. I spotted that early. I go 1 minus secant squared, I can write that negative tangent squared. And secant squared, in place of that, let me put what? 1 plus tangent squared. And you might be going, what do you care if you have a secant or tangent? How is that going to help you? Because I know what tangent x is equal to. See it in the top here? What is tangent x equal to? 5x. So if I do the substitution now, the top will be what? Negative 5 times tangent squared theta. The bottom is going to be 1 plus tangent squared theta. Now replace tangent theta with 5x. If you replace tangent theta, I have no idea where they want to stop, by the way. I couldn't tell you if they'll be happy with this answer. I'm just having a blast there. This is better than watching the 4th of July fireworks. There we go. See, I go, ooh, ah, when I see these hints. What is tangent equal to? 5x. Square it. One plus 5x squared. 25 times 5, negative 125 x squared over 1 plus 25x squared. If the question is find the derivative at 0, 0, what do you care if you go from this to this? It doesn't really make a difference, just plug in the value. It might be easier just to go there and plug in the 0, 0 in it. Make life easy on you. The only problem, you don't have a secant key on your calculator. So what do? 1 over cosine. Gary, go ahead. The 5. Here? How do I get the 5? When you move this piece right here, that becomes negative 5 times secant squared, 5x plus y. And I factor the 5 out all in one shot. So there's a 5 in this, there's a 5 in that. If you factor the 5 out, what's left? There's a 1 here, and there's a negative secant squared, 5x plus y. So that's where it came from. Slow motion, if you want to see it, this is what I have. I took this one to that side. It was 5 minus, when I take this to this side, becomes a minus. Now factor a 5 out of each one. So I took that step out. So that's where it came from. So I just did that one step in my head, then I factor it out. You know. Now they want to find the derivative at 0, 0. Let's finish it. It doesn't really matter what y equal to, because I simplified finally to x. At 0, 0, what's the derivative? X is 0. This is 0 over 1 plus 0. 0. Did they ask for both? Yes. They wanted both answers. And honestly, I couldn't tell you if they'll take this answer or not till you plug it in, or they want it that way. You can try them either way and see. That was 13. And the last one is the 15. Let's make sure I get the right one. Find the slope of the tangent line. At the given point. Find the slope of the tangent line. Number, was it 15? The question was? Yep. The slope of the tangent line at the point 4 over 3 comma 8 over 3. And the problem is x cubed plus y cubed minus 6xy equals to 0. What is find the slope of the tangent line? What does that mean? The slope of the tangent line. That's the derivative. The derivative is the slope of the tangent line. So the question really, what's the derivative? What is dy dx at 4 over 3 and 8 over 3? That's what they're asking you. Implicit differentiation is probably the easiest way. Derivative x cubed is what? 3x squared. Derivative y cubed is what? 3y squared times what? dy dx. Here's the 6. I'll leave in the front. I have x times y. X times y, that's the product rule. The first, so it's x times y I'm looking at. X is the first, y is the second. The first, which is x, times the derivative of the second, dy dx, plus the second, which is y, times the derivative of the first, which is 1. I memorize the derivative of the product rule that way. The first times the derivative of the second, plus the second times the derivative of the first. I find it easier than f times g sub prime plus g times f prime. Yeah. This will be 3y squared dy dx. This will be minus 6x dy dx minus 6y. Anything with dy dx stays on the left side, the rest goes to the right side, because you want to isolate dy dx. So these two got to move. And notice I can factor dy dx from this side. Might as well do it in one step. If you factor dy dx, what's left here? 3y squared minus what? 6x. On the other side will be what? 6y minus 3x squared. And what is dy dx? Now plug in the value at 4/3 and 8/3. Let's see what will happen. Y is 8/3. 6 times 8/3. 6 times 8 is 48 divided by 3. Is that 18? Is it 16? Yep, 16. Minus, I think that's 16/3, because that'll be 16/9 times the 3, that's 16/3. This will be 64/9 times 3, 64/3. Six x, 6 times 4 is 24, divided by 3, is that 8? I'm not really a huge fan of fractions. The best way to fix this problem quickly is you multiply every single term by the LCD. The LCD for these two little fractions, 3. If you multiply every one of them by 3, you'll have 3 times 16, which is what, 48? Minus the 16 over 64 minus 24. That's a 32 over, what do we got, 40? Can we simplify that?
4/5.
Yep, divide by 8, 4/5. So the slope at that point is 4/5. And that's the end of these questions.